Welcome to another episode of Learning in Basic Electric Principles. And I thought in this episode, do one of them that I posted where I'm asking what is Z sub T, that is the total impedance, and the angle. Well, let's get started here. So Z, the impedance itself, is equal to the resistance, which is on the real axis, plus the reactance. In this case, it would be X sub C, which is on the imaginary axis. That's what the impedance is equal to. But in this case, we have no resistance, right? So it collapses to whatever X sub C would be, right? So the impedance actually becomes the reactance, which is X sub C, which is equal to the reciprocal of omega C, where we'll say where omega where omega is equal to 2 pi times the frequency, which we're given here is 60 radians per second. So I like to work on this first, get this out the way. This would be then equal to 2 pi times 60, which is approximately 377. So that's what that comes to. So let's figure out what our capacitive reactance is. Replace these for capacitive reactances. And so what we want to do is, we know that we have 377 that needs to be multiplied times the capacitance here of 44.2 microfarads. So exponent, and we want the negative sign on that. Multiply those two together, and I need to take the reciprocal, and we have about approximately 60 ohms. So our X sub C is equal to 60 ohms for just this one here. And these two together will be added. We're adding these two together. So let's figure out what one of them is, because we add our capacitive reactances to get the total reactance when they're in series. So once again, we would have the same omega, and we just need to multiply that times this. So 377 times 88.4, and that would be in microfarads. Let me change the sign here. Multiply those together, take the reciprocal, and I get 30 ohms. So since these are both the exact same value, C1 and C2, the capacitive reactance for both of those are going to be 30 ohms. This will be X sub C for C3, and then we got X sub C2 would be equal to 30 ohms, and obviously X sub C1 would be also 30 ohms. So the total capacitive reactance here would be 60. So that means we have 60 in parallel with 60. We have these two added together, 30 and 30, parallel with that 60. And that means we can basically not add them together because they're in parallel. So our total reactance would be equal to 1 over the reciprocal of X sub C3 plus 1 over X sub C1 and 2. And what I mean by 1, 2 is I'm going to combine them. 30 and 30 is going to be 60, so that's how we're going to get those together. So let's do that. We're going to get 60 here and 60 here. Basically, that's what's going to happen there. And taking the reciprocal of 60, so 60, I take the reciprocal of that, I get that. I'm going to add this. And so I get 0.033, and now I need to take the reciprocal of that, and I get 30, which makes sense because they're both the same, 60 and 60. Anytime you have two values that's the same, if you had n number of them, let's say you had 4 of them, you would just say 60 divided by 4. In this case, we have 2, so 60 divided by 2 is 30. So that is the total reactance. Notice reactance, not impedance. 30 ohms. So there we have it. 30 ohms. I'm asking for the total impedance. What it ends up being is this. What about the phase angle? Well, it's a completely capacitive circuit. So that means we're on the negative side of the J-axis. So that means the phase angle must be minus 90 degrees. So that's it. Hope this helps. Thanks for watching.